Hi, I'm Vianney, and this is my key activity. So, soaps and detergents. We know that soap is a product for personal hygiene or to wash certain objects, and detergents are made with the purpose to get out of dirty and impurities from an object. It is believed that the first soap was invented in Mesopotamia and the first detergent in 1916 in Germany. So the products that we'll be testing are going to be and comparing will be shampoo. One which is going to be biodegradable and the other non-biodegradable. The biodegradable is a term referring to all of those things that can be decomposed by natural agents and that care about the environment. And the natural agents contain water, oxygen, acid rains, ultraviolet rays of the sun, microorganisms, between others. On the other hand, non-biodegradable substances are never broken down or decomposed by environmental aspects. So this is our first experimental design. First, we need to know that we are going to use our safety equipment, which is our bat, lab coat, our pants with our completely closed, our glasses, gloves, etc. The objective is to test each shampoo and classify their differences between the water pollution and soil pollution. The first experiment will be in water pollution, and our question is, will biodegradable and non-biodegradable increment the pH of the water solution that makes it undrinkable? Our hypothesis is that biodegradable shampoo will have a better solubility with water since its structure is designed so that it can be dissolved in water and does not contaminate water. Therefore, while non-biodegradable shampoo does not have that structure, it will pollute the water and will increase its pH. Our independent variable will be the shampoos that are going to be Head and Shoulders, Caprice, and Garnier Fructis. And our dependent variable, a pollution level that damages the water, and pH. The procedure is that we're going to take 50 milliliters of each shampoo and put it in a cup with 150 milliliters of water. And then we're going to pour it and classify them and see what it happens in one of each of. In our second experimental design, we're going to use soil pollution, and our question is, will there be any damages to the soil if we pour it on biodegradable and non-biodegradable shampoos? And our hypothesis is that non-biodegradable shampoos that are contaminants will get in contact with a plant and will damage it because the substances that it contains are a lot of chemicals and will affect it. Therefore, biodegradable shampoos that are designed to be friendly to the environment and to care about it will not damage the plant in a large scale. Our independent variable is biodegradable and non-biodegradable shampoo, and independent variable are going to are the plant damage. The procedure is to make to grow a bean in a Gerber glass with cotton 5 centimeters, and while it is already grown 5 centimeters, we're going to put it through the biodegradable and non-biodegradable shampoo. These are some of the images of the experiment. This is the biodegradable exposed bean and the non-biodegradable exposed bean. The solubility in shampoos, the left one is the Head and Shoulders and the right one is the Garnier Fructis, which is the biodegradable. The left one has some lumps on the shampoo and wasn't dissolved. So in the analysis, we know that the biodegradable products were the one that didn't contaminate in water and that actually was solving it, while the non-biodegradable increased its pH, and the normally pH of a shampoo it's neutrally and it's 7, and although we know that between 9 and 6 don't usually make really big impacts on the biological culture, it was the pH increase, while in the plant we see that the biodegradable did damage the plant, but in a really large scale and not too much, while comparing it to the non biodegradable, which damaged it a lot, which wasn't taking care about it and make a lot of harm to the plant because of its ingredients that are like alcohol, ethoxylate, ethoxysulfate, amine oxide, between others. And well, our first experiment error was that we couldn't afford to buy our own pH meter, but we talk about someone that works in this kind of stuff so that he could help us a little bit. And the second one was that we didn't start the we start with a little bit of delay and late, so we didn't have the opportunity to have the bean really grow. So we can finally say that in our conclusions, we did find out what our hypothesis says, that the biodegradable products will solve in water and will not harm the plant as much as the non-biodegradable, which it did harm it, and it did even have lamps in the in the water, which make it not to be like not to have not to be dissolved. Finally, in my conclusion, I can tell that we're not even aware of how many contamination can only one person do, and we are billions of people. So yeah, it is a large process to find out the final product to be not harmful at all the environment, and so that we can have that kind of products to be eco-friendly. But at the same time, I think that we should stop using non-biodegradable because they're worse, and while we continue using them, industries won't make any effort to try to change that, to try to help the environment. So we need to know what properties are we consuming, because sometimes they're not even harming the environment, that chemicals are even harming us and damaging us. So we need to take care of us human beings, of every single thing that has a life here in this planet. And yeah, these are our references. Thank you for your attention. Bye.